Solving equations such as x over 5 equals x plus 3 over 8.
Okay. Did I write it correctly?
Yes, sir.
Okay. So what's the first thing we want to do here?
I'm not sure.
Well, usually if you have a denominator on both sides of the equation and there's nothing else, then you want to cross multiply. Cross multiplying is nothing more than doing two steps in one. In other words, we could multiply both sides by 5 to get rid of this 5. And then as a second step, we could multiply both sides by 8 to get rid of that 8. So we just do it all in one step, and it's called cross multiply. So you end up with 8x equals 5 times the quantity x plus 3. So 8x is equal to what?
5x plus 15.
Okay. Now what?
Do we want to divide by 8?
Well, at this point in the equation, we want to gather all the terms with the variable in it on one side of the equation and all the terms with just numbers in it on the other side. So we have an 8x and a 5x. Let's move the 5x to the left side of the equation. Well, when you move something to the other side of the equation, you change its sign. So this becomes 8x minus 5x. And then the final step is dividing by this coefficient, because our goal is to try to isolate x. And you'll notice that if you go back to the original equation and plug in 5, we get 5 over 5 is equal to 8 over 8. Both of them are equal to 1. So we did it right. Okay, you have any others?
1 over 4 minus x equals x over 8.
Okay. Now, this time we have two denominators, but the denominator is only in one term on the left side. So usually, I think the easiest thing to do with an equation that has two denominators is to try to find a least common denominator and multiply every term in the equation by that. And in one step, that gets rid of all your denominators. So what number could I multiply the left side of the equation and the right side of the equation by that'll get rid of all my denominators? About 8. As long as I multiply the left side by 8, I got to multiply the right side by 8. Now let's distribute that. What's 8 times 1/4?
2.
8 times minus x?
Negative 8x.
And 8 times x over 8.
8x over 8.
And the 8's cancel.
X over...
Now, notice how much easier this equation is to deal with than what we started with. This is what we started with. Very difficult. now we got something that's a piece of cake. And the only thing we had to do was to multiply both sides of the equation by this 8 in order to get rid of all the denominators in one step. So help me solve this now. 2 minus 8x equals x.
Subtract 2 from both sides.
Okay, what's the next line of the equation?
Well, then that would be negative 8x equals x minus 2.
Okay, now what?
And then subtract x.
Okay, what's the next line in the equation?
Negative 9x equals negative 2.
Good. And what's the next line?
Divide by negative 9.
So I get x is equal to, becomes positive because we're dividing a negative 2 by a negative 9. All right?
All right.
Most important thing with solving algebraic equations is to try to find a methodology that works and stick with it no matter what the equation. And the methodology that I like is start with getting rid of your denominators and then go from there. So what else you got?
Five over 2x minus 2 over 3 equals 1 over x plus 5 over 6.
That?
Yes.
Okay. What can I multiply? In other words, here I have 4 denominators. So what can I multiply each side of the equation by, which is to say each term of the equation, in order to get rid of the denominators in one step? In other words, there's 2 ways to approach this. I could solve this side of the equation, finding a least common denominator and subtracting these 2 entities. But I really prefer to work with equations that don't have any denominators. So if I can get rid of the denominator in one step, I want to do it. It's going to make the equation so much easier to solve. What if I multiplied everything by 6x? In other words, I'm going to multiply the left side of the equation by 6x. I'm going to multiply the right side of the equation by 6x. What do I get here?
Um, 30x over 12x squared?
Well, it's over 2x, but let's never multiply out the numerators automatically if you can simplify. Notice that this 6 I can turn into a 3 as long as I do that. And the x's cancel. So this first term is really 3 times 5. Okay, what's the second term? What is 6x times a minus 2/3? Multiply the numerators, what do you have?
6.
Yeah, in other words, this is what we started with. 6x times minus 2/3. So whenever you're multiplying a whole number times a fraction, just multiply the numerators. So it's 2 times 6x.
12x.
Divided by 3. which becomes 4x. So the left side of the equation completely eliminated any denominators. Now let's go do the right side of the equation. What is 6x times 1 over x?
6x over x?
Yeah, 6x over x. What is that? X's cancel. That's just equal to 6. What is 6x times 5/6?
30x over 6?
Which is the same as, in other words, I know your inclination is to multiply the numerators, and that's correct. But rather than having to solve 30x over 6, why don't we simplify first? This 6 cancels with this 6. So that's 5x. And if I cancel first, I don't have to deal with numbers like 30. I don't have to know what 30 divided by 6 is, because I'm going to cancel that 6 with this 6. And as all I have left is x times 5. Okay?
Mm-hmm.
All right, so now we have the equation to this format, which is by far easier to solve than what we started with. Let's go back a step. Make sure you understand where I got the 6x from. This is what we started with. How is it that 6x and only 6x, well, 12x would also eliminate them, but obviously whatever I multiply both sides of the equation by has to have an x in it, because that's the only way I'm going to get rid of this x here and this x over here. And it also has to be the least common denominator between the numbers 2, 3, and 6, which is 6. 2 divides into 6 evenly, 3 divides into 6 evenly, and 6 divides into 6 evenly. So that's why I knew that I had to multiply both sides by 6x. That's where I got that from. I'm looking for the least thing possible that will get rid of all of the denominators in one swoop. And that did it. Okay, so what's the next line in solving that?
Subtract 15.
Okay, so what's the next line?
Negative 4x equals negative 9 plus 3.
Plus 5.
I mean 5. I don't know why I said 3.
Yeah, we didn't change that. Okay, now what's the next step?
Subtract 5x.
Okay, so what's the next line? What's minus 4x minus 5x?
Negative 9x equals negative 9.
So what's x equal to?
1.
Very good. See how much easier it makes the whole problem if we can get rid of the denominators in one step?
Mm-hmm.
All right. Now, having said that, I should also add that there's 18 different ways to solve algebra equations. And not everybody would choose the technique that I use. The one underlying thing is that you can always do to the left side whatever you do to the right side. And you can do anything you want as long as you do it to both sides. Not everybody would choose to multiply that by 6x as their first step. That was just one way to proceed. Personally, I think it's the best way to proceed, but it may be that your teacher does it a slightly different way.
Mm-hmm.
What else you got?
15 over x plus 9x minus 7 over x plus 2 equals 9.
Okay. Now, this one's a little different because we don't have a denominator on the right side of the equation. We have two denominators on the left side of the equation. So I still want to get rid of denominators. So let's take a slightly different approach on this one. Let's try to find, we're going to add this fraction to this fraction, which is completely different than what we've been doing. What we've been doing is multiplying the entire left side of the equation by something and doing the same thing to the right side. When we go to add fractions like this, we want to do it slightly differently. What's the least common denominator between these two fractions? When you have variables like this, it's harder, but it's harder to find the least common denominator. But with variables, finding a common denominator is pretty easily. Just multiply them together. In other words, x times x plus 2 has to be a common denominator. The reason being is that what we need out of a common denominator is for one term to divide evenly into it and for the other term to divide evenly into it. Well, x divides into this evenly, resulting in x plus 2, and x plus 2 divides into this evenly, resulting in x. So we know that this is the denominator we seek. So what's the numerator term on the left? Turned off my camera because my computer was complaining. What do we have to do to 15 over x in order to give it this denominator? Well, to give it that denominator, I have to multiply it by x plus 2. But I can't just arbitrarily multiply it by x plus 2. However, I can arbitrarily multiply it by the number 1, which in this case is x plus 2 over x plus 2. So this gives me this common denominator. What's the new numerator of the term on the left? What's 15 times x plus 2?
15x plus 30.
Okay. Now let's do a similar process to the second term. What do I have to do to this term in order to give it this denominator?
Multiply by x.
X over x. In other words, I can multiply it only by the number 1. But in this case, that's going to be x over x. So what's the numerator going to be over here?
9x squared minus 7x.
Correct. And this would be the denominator. So now I haven't really changed the equation much. I just multiplied the left term by x plus 2 over x plus 2. I multiplied this term by x over x. However, now I have something I can work with. How do we add fractions that have a common denominator? Operate on the numerator. And I put a parentheses around that because it's important when I'm operating on the numerator that I'm going to use parentheses there. So in the numerator, how many total x squareds do we have?
9.
How many x's do we have?
Negative 7.
No, we have a 15x over here, and a negative 7x there.
8x.
And how many numbers do we have?
30.
Okay, we're making progress. Now let's get rid of this denominator. How do I get rid of this denominator?
Multiply the equation by...
Multiply the left side of the equation by it and multiply the right side of the equation by it. In other words, this is completely different than multiplying fractions, which I can only multiply by the number 1. As long as I'm operating on equations, I can do anything I want to the left side as long as I do it to the right. Well, when I multiply this left side by this denominator, it gets rid of it and leaves just the numerator. So I now have 9x squared plus 8x plus 30 on the left side. And what's the right side? The right side is 9 times x plus 2. You with me?
Yes.
Okay. Now, in order to simplify and solve this, we need to distribute the right side. So what do we have? When you multiply,
9x
okay,
times 9x plus 18.
18x. In other words, this 9x I can think of without parentheses. So when I multiply this 9x by this binomial, I get 9x squared plus 18x. Still have this on the left side. Now what can I do? Gotten rid of the denominator, which was my goal. Now I need to gather like terms. Get all the variables on the left side, get all the numbers on the right side. Or vice versa. There's nothing that says you have to get the variables on the left side. But I've always found it just makes it a little easier if you always put your variables on the left side, put your numbers on the right. What stands out at you from this equation that you can do immediately, which is quite helpful? Yeah, I can get rid of this. Subtract 9x squared from both sides. Now I have a linear equation. I don't have any squared terms anymore. It's much easier to solve linear equations where the highest power of x is x to the 1. So now I'm ready to gather my variables on one side and my numbers on the other. So what am I going to do next?
Subtract 30.
Okay, so that gives me plus 8x equals 18x minus 30.
and subtract 18x.
That gives me minus 10x equals minus 30.
And then divide by negative 10 to get x equals 3.
That's it. Okay, good. Each one of these has been slightly more difficult, but hopefully you're getting the pattern. And that's all that algebra is there's no secret to solving algebraic equations. It's just remembering the pattern. And the pattern is get rid of your denominators first. If you have radical signs, get rid of the radical signs. If I have this, what's my first step?
Square it.
Yeah, square both sides. Makes this. Now my next step is to add 3 to both sides. Bingo. Pattern is the same on every algebra equation, if you know what it is. And the trick is to memorize the pattern so that you can solve, no matter how complicated of an algebra equation I write, I could write something like this. And you could still solve it, as long as you know the pattern on how to solve it. You'd be able to solve that. And there aren't any algebra equations that are so complicated that this simple pattern won't solve them. So what else you got?
Five over x plus 2 equals negative 1 over x squared plus 7x plus 10 plus 3 over negative x minus 5.
I write that correctly?
Yes.
Okay. Let me rewrite it so I have a little room to work. They're definitely testing you here. All right, whenever you see a quadratic in an equation like this, and it can be factored, factor it. What does that factor into? X squared plus 7x plus 10.
So
how do you factor that? If you don't know how to factor that, we need to review factoring. There's few things more important than being able to factor a quadratic in math. And that'll stick with you all the way up through high school, all the way. You need to factor to be able to do SAT, ACT, or any kind of math beyond algebra, including algebra. So if you don't know how to factor, let's work on that.
we should probably work on that.
Okay, the next step, once I've got it to x times x, which produces x squared, examine the sign of the constant being 10. Since the sign is plus, it means this has to either be minus minus or plus plus. It's the only way you can get a plus 10. If I have a minus and a plus, I would have a minus 10. Now, the reason it's plus plus instead of minus minus is because next I examine the sign on the middle term. Since the middle term is a plus, it has to be plus plus. Now, I'm looking for factors of 10, two numbers that multiply to 10, that because of this plus sign right here, add to 7. What are those? What factors of 10 add to 7?
5 and 2.
Okay. Now let's check and see whether that's correct. I don't really have to check this term. I set it up so that it was x and x was going to equal x squared. I don't have to check the plus 10. When I set it up, I was looking for factors of 10. But I would like to check the middle term, because that's where we frequently have difficulties. So I do that, multiply those two together, I get 5x. I do this, multiply the outside numbers together, I get 2x. Add those together, that should be my middle term. That is my middle term. So let me replace all of this with this. X plus 5 times x plus 2. Now, right offhand, it doesn't necessarily look like that helps much. But look over here, I've got an x plus 2. And look over here, I got something that looks an awful lot like x plus 5, only it's got a negative sign. Well, I can actually change this term quite easily to make it x plus 5 by putting the minus sign outside the parentheses. I'm doing that. And now I can actually take that minus sign and combine it with the plus sign so that it looks like this. So now my problem is this. Minus 1 over x plus 5 times x plus 2. Now, what quantity can I multiply every term in the equation by to get rid of all the denominators in one step?
We have to have the x.
Remember that you always have to multiply by the most complicated looking thing you're looking at. In other words, if I multiply both sides by x plus 2, I don't get rid of this denominator. If I multiply both sides by x plus 5, I don't get rid of this denominator. So how am I going to get rid of this denominator? Multiply both sides by this denominator. That will get rid of this x plus 2, it'll get rid of this denominator, and it'll get rid of this x plus 5. You see how that does that?
Yes.
Okay, so what am I going to be left with on the left side of the equation when I multiply every term by this? What's the left side become? 5 times what?
The x plus 2?
Well, we have to multiply. The x plus 5 sticks around. The x plus 2 cancels. You see how? In other words, I don't have enough room here, but I'm going to multiply this by x plus 5 times x plus 2, and the x plus 2 cancels. So I'm left with 5 times x plus 5. It's the only thing left on the left side.
5x plus 10?
5x plus 25.
Yeah, 25.
But let's finish the right side, because we're not quite there yet. When I multiply the right side by this denominator, what does this term become?
Three times x plus 2?
No, I'm multiplying everything by this. In other words, whatever I multiplied the left by, I have to multiply the right by. Well, I have to do it term by term. So the first thing I have to multiply the right side of the equation by is that. Multiply it by x plus 5 times x plus 2 cancels. I'm left with minus 1. Minus, I've got to multiply this term also by x plus 5 times x plus 2. So what does this last term become?
3 times x plus 2?
Yeah, which is 3x plus 6, but this negative sign has to be applied to that whole thing, so it actually becomes minus 6. And now we are facing an easy problem to solve. It went from being very difficult because all these variables in the denominator. Once I got rid of all the denominators, it's pretty easy. This is 5x plus 25. What's this simplify to?
Negative 3x minus 7.
Okay, keep going. Gather your variables on one side, your constants on the other.
Subtract 25.
Okay, so subtract 25 and add 3x, and I'm going to do those at the same time. In other words, there's no need to really do that in two different steps. So I'm going to add 3x. I'm going to subtract 25 to get to that step there. In other words, I go from there to there directly. Now, there's the solution. That was difficult, but not really. It was just a bunch of steps, which are always the same. In other words, the first thing I saw when I looked at this was this quadratic. So the first thought in my head was, let's factor that quadratic. Once I factored it into x plus 5 times x plus 2, well, I recognize that. That's everywhere. Here's the x plus 2, and this is a very modified version of x plus 5. That's a negative parentheses x plus 5. So that's what you want to do on all of these. You got another one like that? Or something different?
One second.
Okay. We've got about 20 minutes. So we got enough time to cover 2 or 3 more problems, especially if they're hard.
7x plus 3 over x squared minus 8x plus 15 plus 3x over x minus 5 equals 1 over 3 minus x.
Okay. Again, what's the first thing we see here? The quadratic. Let's factor that. That's going to be our first step. So, factor x squared minus 8x plus 15 for me. Let's do it methodically. What's the first step I'm going to do?
X. I'm going to number that.
Now what? Now that I got my first term, in other words, I'm factoring this into 2 binomials. I'm going to have an x plus or minus something times an x plus or minus something. So what's the next step? We examine the sign on the constant, which tells us what about the signs that have to be down here. What would create...
They have to be either both positive or both negative.
And which are they? That's correct. They have to be either both positive or both negative. How do we tell which they are?
We're looking at the second.
So they're both negative. Now, we look at the constant. What is our goal?
Multiply to get 15.
No, we want factors of 15 so that the two numbers do multiply to give you 15, but they also have to add, because of this plus sign, to the number 8. Not to minus 8, but to the number 8. So what factors of 15 add to 8?
3 and 5.
So we factored it. So I'm going to erase this and replace it with the factored form. Factored form is almost always better than the unfactored form because you can do stuff with it. Now, what looks similar? What looks the same?
X minus 5 to the other x minus 5 and x minus 3 to the 3 minus x.
Yeah. How do we change this 3 minus x into an x minus 3, which would make the problem so much easier?
Well, couldn't we just switch since it would be the same?
We put a negative sign in front of it. In other words, here, let's go over that. Before I do that, let's cover that principle. A minus b is always equal to the negative of b minus a. Notice that 9 minus 7 is going to be equal to 7 minus 9. This is negative 2. Negative 2 is positive 2. So no matter what a and b are, if I'm subtracting them and I have the reverse, I can always make that be x minus 3 by sticking a negative sign in front of it. And it doesn't matter whether I stick the negative sign in the denominator or the numerator. It's the same. In other words, these are all exactly the same. 1 over minus x minus 3. Notice that that's the same as that. But I can also write it as negative 1 over x minus 3. I can also write it as negative 1 over x minus 3. All of these are the same. Well, it's going to make the problem a whole lot easier if that says x minus 3 as opposed to 3 minus x. So let's choose this option here and make it say minus 1 over x minus 3. So now we haven't really changed anything. We haven't done anything to this equation yet. But now we have it in a form where I can eliminate all denominators in one step. Tell me what I have to multiply both sides of this equation by in order to do that.
We'd have to multiply by the x minus 5 and the x minus 3.
Exactly. I'm going to multiply this term by that. I'm going to multiply this term by that, because they're on the same side of the equation. And I have to multiply this term by that. Now, what do I have left? What's the left side? What does this whole thing become?
Just 7x plus 3.
What does this whole thing become?
Three x times x minus 3.
Okay, so that is 3x squared minus 9x. And the right side becomes what?
1 times x minus 5.
Don't forget this negative sign. Remember, we had to add it there. So it becomes negative x minus 5. And if I want to get rid of the parentheses, that becomes negative x plus 5. So let's do that. All right. Now everything's really simple. I can attempt to solve this. What is this kind of an equation? How am I going to solve it? Is it a linear equation or a quadratic equation?
Quadratic?
Yes. And the way we solve quadratic equations is we put everything on the left side and 0 on the right. So we solve quadratic equations much differently than we solve linear equations. If I have something like this, I can solve it. I got the variables on the left, the numbers on the right, divide both sides by 7, I get that. Quadratics, we can't solve that way. Quadratics, we have to put everything on the left and factor and put 0 on the right. So if I'm going to put everything on the left, how many total how many x squareds do I have? Excuse me.
3.
How many x's do I have on the left side by the time I move all of them over to the left side?
Negative 3.
Well, we got plus 7x, minus 9x, that's minus 2x. Then I have to add an x to get rid of this one, so that makes minus x. That gets rid of that, and that at one time. How many numbers do I have?
8.
Well, not if I move this one over to the left side, I don't.
Negative 2.
What am I left with? On the right, 0, which is what I want to be left with. The reason I want this to be 0 is because I'm going to factor this into two things times one another. And in algebra, whenever you've got two things times one another equal to 0, one of them has to be 0 so we can solve the equation. I don't have any way to solve this other than trying to factor. So let's try to factor this. What are my first two terms going to be? Or I should say, what's my first term in each expression going to be?
X.
Well, it can't be x and x because that multiplies to give you x squared, not 3x squared. So what are factors of 3x squared? About those two. X times 3x is 3x squared. Okay, now the rules are a little different. And the rules become different because this coefficient is not the same as this coefficient. This is a 1, this is a 3. So all of the rules that I've been telling you about factoring no longer apply. It now becomes a bit of a trial and error game. We still do, we examine that. What does that tell me? About the signs.
That they can only be positive and negative?
Yes, they have to be different. But the thing is it could be this way, but in this case, because this 3 is different than this 1, it could be the other way, and it would be different. So we're going to have to experiment a little bit. Luckily, there's not very many factors of 2. So let's try every combination. What are factors of 2? In other words, I guess what I'm trying to say is I can no longer say that I'm looking for factors of 2 that subtract to the 1. Can't do that anymore because of this coefficient in front of this x. However, what are the factors of 2? There's not very many.
1 and 2.
Okay, let's try that. 1 and 2. Does that work? work? Does that produce the proper middle term? We know it produces 3x squared, and we know it produces negative 2. Does it produce a negative x in the middle?
No.
Well, actually it does. That's minus 3x when you multiply the two inside terms. When you multiply the two outside terms, you get 2x. Add those two together, you do get negative x. So that worked. But I was lucky that it worked on the first trial. Notice that if I'd have started with 2 and 1 like that, that doesn't work. That does not give you a middle term of minus x. So maybe I would try next, let's try plus 2 minus 1. That also doesn't work. So let's try plus 1 minus 2. That doesn't work either. There's only one other combination, which was the first one we happened to come on, and that would be minus 1 plus 2. So for factoring more complicated quadratics where there's a coefficient in front of the x squared, it's kind of a process of trial and error, more so than the other is. I don't have a standard set routine that will always work. I mean, make this a 12 and the problem becomes super hard because now there's all kinds of factors of 12. I would have like 8 different combinations I would have to try. But they're not going to give you a 12 here. They're going to make these easy. In other words, there's only so many factors of 3 and there's only so many factors of 2. So now how do I solve it once I get it to here?
Distribute?
No, we just undistributed. In other words, that's what we were doing when we factored that, was breaking it into two things multiplied by one another. If I've got this multiplied by this is equal to 0, what does it say about either one of these? How can two numbers be multiplied together equal to 0?
By the -1 power?
The only way, you give me two numbers that multiply together to be 0 and have one of them not be 0. You can't do it. You can multiply 1/4 times 4 over 1, that's 1. There's no way to multiply two numbers together and get 0 unless one of them is 0. So that gives us a way to solve that. We can now say that x minus 1 has to be equal to 0, or 3x plus 2 has to be equal to 0. And each of these is easily solved. For the first one, what is x equal to?
1.
And for the second one, what is x equal to?
2 over 3?
-2 over 3.
-2.
So those are two solutions right there. And quadratics almost always give you two solutions. The moment you get this into a quadratic, you know you're going to have two solutions. Because it's always going to be something times something else equal to 0, and we set that equal to 0 and solve, and we set that equal to 0 and solve.
Okay.
Okay. Got another one? We got time for one more, maybe.
Five over x squared minus 7x plus 12 minus 2 over 3 minus x
Hold on.
equals 5 over x minus 4.
Back up to the beginning. was this 5 over a quadratic?
Yes.
Okay. So the way I would verbalize that would be 5 over the quantity, x squared, what was the rest of it?
Minus 7x plus 12.
Okay. Because, see, from listening to it, I couldn't tell whether this minus 7x plus 12 goes over here all by itself or it went with the denominator. Okay. What else?
Minus 2 over 3 minus x equals 5 over x minus 4.
Now, given the nature of the problems we've been doing, every one of them has been the same. We need to come up with something to multiply every term in the equation by that gets rid of the denominators all at one time. And the pattern is always the same. Let's factor that quadratic to begin with. And you want a clue? Look to here. Those figure to be the factors, right?
Right.
Based on every other problem we've done? So what are the factors?
Minus 4.
Yeah. Notice that gives you a middle term of minus 7x, gives you a plus 12. Okay, now this isn't quite x minus 3. What do we have to do to make this x minus 3?
Put a negative in front of the variable.
Right. And a negative times a negative becomes a positive. So now I can write it like this. Again, what do we have to multiply every term in the equation by in order to get rid of all the denominators in one step?
X minus 3 and x minus 4.
X minus 3 times x minus 4. So what does this term become?
5.
What's this term become?
2x minus 8.
And what does this term become?
5x minus 15.
Now isn't it a much easier problem now? Gather all your variables on the left, all your numbers on the right. What do you get?
Negative 3x plus 12 minus 12
Good.
equals, yeah.
Because I had a net negative 3 over there, so I had to add 3 to the right, turn that negative 15 into negative 12. Problem. What's the problem with that solution?
It only has one solution?
No?
Or it's not equal to 0?
Notice that in the original equation, if x is equal to 4, I'm dividing by 0. Both here and here. Well, that's one thing you can never do. In other words, if the only solution to this problem is x equals 4, which it was, well, when x equals 4, this whole thing equals 0. So does this. So I'm dividing by 0 twice. Can't do that. There's no way x can equal 4. So this problem has no solution. In other words, the only solution we came up with causes division by 0, which violates everybody's 10 commandments of mathematics. That's number 1 on everybody's list. You cannot divide by 0 under any circumstances. So when we come up with a solution, x equals 4, and we plug it back in to the original equation, we see division by 0. So we immediately say this has no solution. All right, glad we did that last problem, because that was a tricky one. All right, Jake, our time's up. Hopefully I've been helpful tonight.
You sure have.
All right, I'll talk to you next time.
All right.
Bye-bye.